Okay, so in this video we're now going to look at some application problems involving parabolas, and I'm going to work through two examples which give two fairly typical problems involving parabolas. In terms of application problems, they probably come in two categories. One of which would be that you are given a quadratic equation that describes some sort of phenomenon or some sort of shape. And then you answer questions about the situation using the equation you've already been given. And the second type of application would be where you actually need to generate the quadratic relationship yourself from the information in the problem. And as I'm sure you can predict, that's obviously the harder kind of question, and we'll have a look at that in the second example. I'm also going to look at utilising my CAS as much as possible to help me throughout this. That's not to say that these questions cannot be answered without your CAS, but I'm trying to build in that sense that whenever we're dealing with application and analysis kind of problem, those sorts of questions usually happen in a tech active exam, and so getting used to how to use your CAS to help you to be more efficient is important. So I want us to think through that as we go. Okay, let's just have a look at the first example. So we've got the height, h meters of a rocket, t seconds after it is fired vertically upwards, is given by h of t equals 80t minus 5t squared, where t is bigger than or equal to 0. Okay, now we can do this in two different ways. Okay, we can define our function in the calculator screen, which is probably what I'm going to do here, but I might run through the problem as well if you did it differently using your CAS. Or apologies, or you might choose to first of all sketch the graph to have a look at what's happening, and then I would use the function definition that happens when you sketch a graph. Okay, so I'm gonna define the function myself here, but I'll also have a look at how you make, just a recap on how you make use of that definition if you draw the graph first. Okay, so menu 1.1 to define a function. A function is h of t, and you must use function notation when you define an equation in your CAS so that you can then substitute into it easily, solve it, etc. Your CAS won't understand what you're talking about otherwise. So it's 80 times t minus 5 times t squared. Okay, and there's my function. My CAS now understands whenever I type h, you see it comes up as bold. It's recognising something is stored as h. If I type h of t, it knows that h of t is 80t minus 5t squared. Okay, so we should never have to type that expression again in our calculator. You shouldn't be typing 80 times something minus 5 times something squared in your CAS once you've defined it. Okay. Alright, so let's think about the problem. So we want to find the height of the rocket after 3 seconds. So find h when the time is 3. Okay. So in terms of using our function notation efficiently, both in the CAS but also in terms of what we need to write down, we don't need to write down when t equals 3, h is equal to 80 times 3 minus 5 times 3 squared, because that's exactly what is said by writing h of 3. Okay. Replacing the t's with 3's, my CAS will automatically do that when I type h of 3. It is quite literally wherever there's a t, putting a 3 and then working out what that is. Okay, so you're not solving anything here. There's no rearrangement required in order to solve for h. H is already the subject. Your CAS is simply working out 80 times 3 minus 5 times 3 squared. Okay, so simply on the paper writing down h of 3, that's not CAS notation, that's maths, that's good use of function notation, is equal to 195. So after 3 seconds, and we've got units in this context, so we want to include the units in our answers. After 3 seconds, the rocket is at a height of 195 metres. Find, to correct to one decimal place, the time or times at which the rocket is 100 metres above the ground. Okay, so this time we want to find t, okay, when h is 100. Okay, so again, using my function notation, I want to therefore make 80t minus 5t squared, which is h, equal to 100. My CAS will do that if I type h of t equals 100. Okay, now if that's all I type and press enter, it'll just give me the equation. Because now, this is different to the previous example where you're not substituting into the rule, you're making the rule equal to something. And so there's an additional step that then needs to happen once you make the rule equal something, which is that you need to solve for t. Okay, So I wouldn't just type h of t equals 100, I wouldn't have typed that line at all. I would instead type solve menu 3.1 h of t equals 100, which will make the equation for me, and I want to solve that for t. Oops, sorry. Press enter. Okay, now it'll just give me an exact answer because my CAS should be set to auto calculation mode, where if it can find an exact answer it will. And that's great because in maths methods we always want to answer exactly unless we've been told to round. But in this particular question, we've been told to give a rounded answer to one decimal place, so we want our answers as decimals. So instead we press Control Enter to evaluate to an approximate answer, so to get a decimal answer. Now, if you have to solve an equation using your CAS, you must make sure you've written down the equation. So it doesn't need to be any more complicated than you writing down that you solved h of t equal to 0, but you must write that down. And then I can see here that t is going to be, I'm going to write approximately equal to, because I'm rounding my answer, 1.3, oh no, sorry, 1.4 when I round that, or 14.6, and the units there are seconds. Okay, so part A would only be a 1 mark question. There's no solving required, it's a straight substitution. 1 mark for the answer of 195. Part B would be a 2 mark question. You have to decide that there is an equation that has to be solved here, and you must write that equation down on the paper, and then you give your answer. You do not write the CAS syntax. I don't want to see solve for t. Okay, that's the language you use to talk to your particular brand of TI Nspire calculator. If you have a Casio, it probably uses different syntax to that. It's not maths, it's just the language you have to communicate with your CAS. In a Tech Active paper, you write down the equation, you then follow that with the answer. If it's a Tech Active paper, we know you used your CAS to get from equation to answer. You've got a calculator, you got straight from the equation to answer, that's how you did it. You don't need to tell us using CAS, you don't need to write the CAS syntax on paper. Simply write the equation and then write the answer. Okay, so we've got 2 times when the rocket's at a height of 100 metres. I want you to think a bit, take a moment to think a bit about the context and what's happening here. Why are there 2 times when the rocket's at a height of 100 metres? I'm not going to answer that for you right now. Have a think about what's happening with this rocket. What kind of model is defining the height of the rocket? What happens after the rocket's fired? Okay, how long does it take for the rocket to reach its maximum height? Okay, so I'm actually probably going to answer some of the questions I posed of you in Part B here before we get into this. So we want to think about the maximum height of the rocket. What we've got here is a equation involving height and time, which is a quadratic, and it's a sad parabola. Okay, so it's doing this basically. Okay, as time changes, the height goes up initially and then it comes back down to the ground. So the rocket, if I want to know about its maximum height, the maximum height is going to be that. So therefore, I need to know about the turning point. Now I could faff around with the graph in my CAS, but it would only give me a decimal answer, and I might not want a decimal answer, and it would be very time consuming. I know, for any quadratic, I can find the turning point when I convert the quadratic to turning point form, and I do that through completing the square. So I'm going to get my CAS to complete the square. Menu. Even if you don't know how, even if you went, oh, I didn't know my CAS could complete the square. A, if you were in my class last semester, you should. But B, you don't have to know this stuff. You've got a tool here that will do algebra for you. It absolutely can do any algebraic process that you've learnt to do by hand. So, don't be afraid to press buttons. Press the menu. Okay, I didn't know it could complete the square, but let me see if I can work it out. Alright, I've pressed menu. Which of these options do I think is going to be best? Well, it's an algebraic process. Why don't I try number 3 for algebra? And look, there it is at number 5. Don't be afraid to press the menu button and to explore and see if it can do what you want it to do. So menu 3.5 for complete the square. Again, I don't need to type my expression in again, I just type h of t, and my CAS knows that h of t is 80t minus 5t squared. And you do need for complete the square comma t, which seems a bit excessive, and it's because if you've got an expression that has more than one unknown in it, you can still complete the square, so you need to clarify which unknown you want to complete the square around. Similarly, a bit later in the semester when we look at graphs of circles, we need to complete the square for 2 different variables. We can do that all at once. Okay, so complete the square for h of t, complete square for h of t in terms of t, and we get this. Now, we would normally write that as negative 5 times t minus 8 squared plus 320. That would be a more standard turning point form for us. And so from that, we can see that the turning point has coordinates of 8, 320, and so therefore the maximum height is 320 metres. Oh, sorry, it didn't ask me for the maximum height. That's my answer to part D. Let's just move that down there. Okay, so therefore, after max height occurs when t equals 8 seconds. So after 8 seconds, it will be at its maximum height. What is the maximum height? So it's just the y-coordinate of that turning point, or the h-coordinate in this instance. And then how long does the rocket spend in the air before it lands back on the ground? So this requires us to know about our x-intercepts. Now, if we use the symmetry with the turning point, you can calculate the x-intercepts pretty easily. You can work out that that second one will be at 16. But if you haven't thought that through, or if the equation is more complicated and it's not quite so symmetric, because perhaps sometimes you might see this sort of thing happening. It's been fired from a platform, so actually you haven't got symmetry with the y-intercept and the other x-intercept. But we're going to find the x-intercepts. We want to make the equation equal to 0 and solve that for 0. So I have to write down the equation I'm going to solve. Then I get my CAS to solve it. H of t equals 0 for t. And so we get t equals 0 or 16 seconds. Okay, how long does the rocket spend in the air? So they're just the t-intercepts. So therefore it spends 16 seconds between 0 and 16 in the air. Okay, so that's a fairly straightforward example where you're given the function, you then use that to answer questions. But I want to think about how by defining the function at the start of the question, you can then quickly and easily obtain all the answers you need. I'm just going to clear my screen here, menu 1.5. It won't clear that function definition, but that's okay. I'm just going to go over to the graphing screen. Actually, before I do that, I've still got h of t's defined, because I didn't actually delete the variable. I just erased the whiteboard. I didn't erase our memories. So, for example, you'll be able to see if I type h of t, it still recognises that. Just before I look at a slightly different approach to the question, if you had wanted to sketch the graph, having made your definition over here, so tab over to or press the scratch bar button to change over to the graphing screen, tab to open your entry line if it's not there, and then you shouldn't be retyping your equation over here, but there is one thing you need to think about. So if I type h of t here, my CAS will prompt me about a slider for t. And that's because my CAS doesn't have a t-axis. You can't just change the axes from x and y in your CAS. So it thinks that t is a variable that I want to play around with changing, like we did at the start of this topic when we had to play around with what the parabolas look like. So I'm going to press cancel here. No, I don't want to make a slider. Okay, now what I need to think about is my CAS, you see here you've got f1 of x. If you're going to draw a graph in your CAS, it must be in terms of x. Now let's think about the fact that my CAS understands that h of t is equal to, what was the equation again? 80t minus 5t squared. But I need to have 80x minus 5 times x squared for my CAS to be able to draw the graph. I don't need to retype it, because if I just type h of x, my CAS literally puts x's in place of all the t's. Okay, so it's very simple to change the variable to x in your graphing screen, h of x, and it'll draw the parabola. Now, again, you need to combine together your understanding of CAS with your understanding of the function. You know this is a sad parabola. It's not broken, it's not drawing a straight line. If you think a bit about it, if you think a little bit about this, you've got some quite big numbers here. Maybe you do a little quick factorisation in your head and you take out 5t, and you're going to have negative t squared plus 80 divided by 5 is 16. Okay, so you know it's got, sorry, there's no t there. You know it's got x-intercepts at 0 and 16 if you think through the factorising. So, okay, at very least we need to change this maximum x value to be somewhere past 16. I'm going to make it 20. Now at least I can see the two x-intercepts. I can also now see that clearly it's very stretched. So I'm going to increase this value here. You might try 100 to start with, and then think, oh, that's not enough, and then increase it. Now we've already done calculations here, and we know that the maximum's at 320. So if we make this 400, great, now we can see the parabola. I don't like when the x-axis is so squashed at the bottom, so I might just make that minus 50 just so I can sort of actually see the x-intercepts. Okay, but you can see your graph. If you then wanted to find h of 3 on the graph, it would be tedious, but you can. Menu, 5 for trace, 1 for graph trace, and then you can just type 3 and press enter, and it'll jump to the point on the graph where the x-coordinate is 3. Now, this is fine in this function where when x equals 3, the y value is a whole number. But if that was a decimal, it would be rounded, it would be difficult to read. So what I would do instead is I wouldn't have done that. I would have, if I'd drawn the graph first, I'll come back to this. Let me answer a few other questions here. So you could also solve h of t equals 100 with your graph, because you could draw the graph of y equals 100 and then find menu 6 points of intersection. Okay. Your CAS only works in decimals, okay, but in this case we wanted decimals, so that would be okay, but that's also pretty tedious. And it's easier for me to do on the computer version of the CAS, but it's really tedious on your handheld. You can find your turning point, menu, 6, maximum point, somewhere to the left, somewhere to the right, okay, and in this case it's a nice whole number, it's showing us the point nice and exactly, but that won't always be the case, and if the numbers were just a little bit bigger than this, we would also get some added problems we would need to deal with in the graphing screen, okay. And you could obviously find your x-intercepts, menu, 6, 1 for 0, and somewhere to the left, somewhere to the right. Again, fine because it's a whole number, would be more problematic in a different function, okay. I'm just going to delete this here, and instead I'm going to ignore my function definition and pretend that I never defined the function over here, that instead the first thing I did was draw the graph. Okay, so instead I actually typed the graph in over here, and I typed it in as 80x minus 5x squared. Great. Again, you can find your points in the graphing screen, but I wouldn't. I would only ever draw a graph to get a look at it, so adjust my window so I can see it, get a sense of what's happening, and then I'd find all my key points over on the calculator page. So here, if I then wanted to sub 3 into this equation, I'd go across to the calculator page by pressing my scratchpad button, and I know my function is defined as f1 of x. So over here in my calculator, f1 of 3. So if you draw the graph first, that's fine. You use your function 1 definition. Okay, again, solving f1 of x equal to 100 for x. Oops, sorry. For x. Control enter for a decimal. Get my values I want there. Again, you need to be a bit careful when you're working with x in the calculator and t in the on the exam paper or the test paper. You must make sure you use variables consistent with the question, so your answer should all be about h and t, even if you're using f and x in the CAS. Okay. You would find your turning point by completing the square, but you would complete the square for f1 of x, and it would be in terms of x. Okay, that gives you your turning point. And you would solve your equation equal to 0 for your x-intercepts. Now again, efficiency with your CAS, rather than retype solve f1 of x equal to 0 for x, I'm going to scroll back up here where I did another solve, press enter to copy that down, just change the 100 to 0, and enter to solve. Okay, so quick and easy. Even if you want to draw the graph first, you still want to make use of the function definition to find all the key points on your graph. Okay, let's have a look at the second example where we need to actually come up with our quadratic equation ourselves. So a farmer needs to construct a small rectangular paddock using a long wall for one side of the paddock. He has enough posts and wire to erect 200 metres of fence. What are the dimensions of the paddock if the fences are to enclose the largest possible area? Okay, so there's already a fixed wall up against which he wants to construct a paddock. Okay, so he's got the fixed wall there, so he's only building 3 sides of the rectangular paddock. Okay. Now, it hasn't instructed us what variables to use here, so we can call them whatever we want. Let's maybe go with x and y. You can go with L and W. I personally don't like L in equations. It looks a bit like a 1, or, you know. Anyway, so I'm going to go with x and y. Now, we want to enclose the largest possible area. So it's area that we're interested in. So we want to come up with an equation for the area. Okay. So we know that area of a rectangle is length times width, which in this case is x times y. But we've got three variables in that problem, so we can't draw a graph of that to see what that looks like, to get a sense of where the maximum is, okay? So we need to eliminate one of the variables, and that's where there'll be some other information in the question that enables us to connect x and y to each other, and that is this 200 metres of fencing. So that means that the total fencing length is going to be 200 metres, okay? So that means that 2 lots of x plus y is 200. So we've now connected x and y, which means that we can very easily make x or y the subject in this little equation and then substitute it into our area equation. Now it's going to be neater to make y the subject here, so I'll do that, but you would be able to solve the problem by making x the subject. So y is equal to 200 minus 2x, so that is y. I'm going to put that into my area equation, so now that my area equation is only in terms of x. Now we can write that equation in whichever way we want. I might recognise there's a common factor of 2 in that bracket, and I might take that out. I might completely expand out the brackets and instead get 200x minus 2x squared, okay? Whatever version you've got it in, it doesn't matter. We've come up with an equation for the area, and that's a quadratic equation. Okay, so we're interested in maximum area, and actually what we're seeing is our area equation is a sad quadratic, okay? And so maximum area is going to be all about thinking about the turning point of this quadratic. Now this is a nice easy quadratic, and they quite often are in these area problems, so actually it's quicker and easier for me here to sketch this quadratic by hand than it is to use my CAS. This version here is particularly helpful. From here I can see there are x-intercepts at 0 and at 100, okay? So x-intercepts at 0 and 100, sad parabola. Turning point, therefore, is going to happen at 50, okay, halfway between. And so we're going to have a sad parabola, 0 to 50. Now, sometimes these questions will be more broken up for you. The first question will be part A, let x be the width of the paddock, express the length in terms of the width. That's what we did here. Part B would be show that the area of the equation is given by one of these. So that would be about subbing my y value in and then simplifying to whatever the question specified. Next, it might ask me to sketch the graph of a versus x, and it will probably say something like, for suitable values of x. Okay? In which case, I know that area can't be negative, and I know that length can't be negative, and so I'm actually not interested in anything that happens down here or anything that happens back here. Okay? So actually, what I would do is my parabola would actually not be that whole thing, it would just start and finish at those endpoints. I know the x-coordinate of that is 50 because I know about parabolas and I know about the symmetry of them. So if I want to find the maximum area, I need to find the area when x is equal to 50, okay? So I know that the maximum area is when x is equal to 50. So let's sub 50 into our equation. You could sub it into any version of your equation. I might go into the factorised version. So I might go into the original version actually. So it's going to be 50 times 200 minus 2 times 50. So that is 50 times 200 minus 100, so 50 times 100. So it is 5,000 square metres would be the maximum area of the paddock that I can create. And then I want to be clear about having answered the question. So the question says, what are the dimensions of the paddock if the fences are to enclose maximum area? So I actually didn't want to know the maximum area. I actually didn't need this. Okay, that's not asked for. I want the dimensions. So I know that the width here will be 50. Okay, and I then therefore want to know what does y equal when x equals 50. So when x is 50, y is 200 minus 2 times 50. So that's 100. And so therefore the dimensions for maximum area are 50 metres by 100 metres. Okay, so be clear about what the question's actually asking you for. Does it ask you for the maximum area? Does it ask you for the x value that gives maximum area? Does it ask you for the dimensions? Making sure that you've actually answered the question at the end. Okay, some application questions for you to work through in exercise 7F.